friends, we're looking at these heart rates.
Them are two.
And the first thing I'm going to do is I'm going to list them least to greatest. Otherwise, our data doesn't make any sense. So I got 72, 75, 76, 76, 78, 70, nope, 77, 78, 79, 81. Ooh, I got to sneak that one in. Okay. So what is the interquartile range? So the first thing I'm going to do is I'm going to find my median. My median appears to be right here. So to get my quarters, they're right there.
We did it all right.
So for my interquartile range, the high end is 78.5, the low end is 75.5, and that gives me an interquartile range of 3 beats per minute. And what that means is half of my data is within 3 beats per minute of the median. Here's what it looks like on a box and whisker. Okay, so 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 80. Okay. We'll do it like this. 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82. Okay. So 75.5, 76.5, and 78.5 are my median and quartiles.
I think it is.
My low is 72. My high is 81.
No, it's 2.5. It's 2.5.
So, what this 3 beats per minute is saying is half of my data points fall within the interquartile range, in that box portion. Now, that is a measure of this word that we're going to use today is variability. The word variability means like how much is it changing by. So, if most of my data, not most, half of my data is within 3 beats per minute, does that seem like there's a lot of change in data, or is it all pretty close together? Pretty close together. And the 3 tells us it's pretty close together, but if we had the same interquartile range, being 3 with something else, like let's say fingers on your left hand, would that be close data or far data? High variability, right? If we're talking about a hand, a difference of 3 fingers. But what if we were talking about millions of dollars? So it's kind of relative, right? We got to think. So I think 3 beats per minute when we're talking 70, 80. That means half our data is really close. Okay. So this is a measure of the other word we're going to use today is central tendency. How much of our data is toward the center? So what do we call the center when we're doing a box plot? The median. So it looks like in reference to the median, half of our data is within 3 beats per minute. We're pretty close, right? So this other stuff, when we split it up into our quarters, we had 2 at each, right? So 2, 2, 2, 2. That's kind of the easier of the 2 questions, I think. Ivy. Yeah, so we can summarize that. So if we want to find the interquartile range, we can do quartile 3 minus quartile 1, and that would tell us the range of values within that half of our data. All right? And again, that's pretty useful saying half of our data is in this one area. If it's a big spread, we know we have high variability. If it's a small spread, we know we have low variability. And, most high schoolers are going to be similar age, similar-ish size, weight, right? So it makes sense that the heart rates are pretty similar. Now, if it was in different classes, you have a kid in PE versus a kid in language arts, heart rates might be different, right? But there's low variability here. So let's talk about, these are just 2 things. There's no computation needed for this. We got this pod of dolphins. There's 800 dolphins. The median length of dolphins is 5.8 feet. So what's the only conclusion we can pull from this? What information does this tell us?
Average amount of dolphins are 5.8 feet.
Well, the median is, right? So if you listed all the lengths, least to greatest, the one in the middle is 5.8. So what does that mean in context of all of our dolphins, Sean?
Half the dolphins are less than 5.8, and then
Yeah.
half the dolphins are more than 5.8.
Yeah, or half dolphins are 5.8 or less, and half are 5.8 or more. Because 5.8 is the exact middle of our data. Half are higher, half are lower. Or maybe there's several that are 5.8 and 5.8 lies within that data, right? Cool. Now, there's a vocabulary test, 50 questions, given to 600 students, so quite a few students, right? And the interquartile range, or as we talked about, quartile 3 minus quartile 1, gave us a difference of 40 correct responses. What does that tell us?
That, there's like four.
So half of the data is in a range of 40 questions. What does that tell us in terms of let's
The full is 80.
the full is 50. 50 questions.
Average is 40 correct.
Not the average is 40. The interquartile range is a difference of 40
What if they
questions.
all
Ivy?
got 100%? Uniform.
High variability.
600 people.
Yeah, and the reason for it's going to be 5th to 10th grade, right? So they're going to have different skill set. But there's high variability because half of the scores have a swing of 40 points out of a 50-point test. That's a lot of the points, right? Now, but there's 5th graders, if they're high school awards, they wouldn't do very well, right? So that's probably, some might, some wouldn't. But if, let's say this interquartile range was 10 points, that'd be way less variability in scores, right? So this is just showing, all we can take from that is the scores are all over the place a little bit, right? And then also there's a lot of really low scores and really high scores. Because even though we don't know what the scores are, if there's a range of 40, there's a quarter that's above whatever that 40 cutoff is and a quarter that's below. So that means we have some concentrated extremes too. Maybe I'll put that in parentheses, concentrated extremes. But really what we know is high variability. The first thing we needed to do
Wait a minute.
was find that the average of our data set, or the average heart rate of these high schoolers, was 76.75 beats per minute. We're all good? So the next thing I found was how far away it was from the average, the deviation. Well, if it's just straight up deviation, we're going to do the average minus the data value, and I got negative 4.75, negative 1.75,
How did you get that?
4.25 by subtraction, negative 0.75, negative 0.75, 0.25 away.
I get it
I
now.
got 2.25 away, and then 1.25. So I personally would skip that column and jump right to this last column, because absolute deviation is just
The numbers.
that number, how far away it is. No positives or negatives. It's just this far away. Okay. So really right now is what I've got a list of is how far away each data point is away from the average. Everybody good with what I've got? So to get the MAD, or the mean absolute deviation, I'm going to find out on average how far away these all are from the average. So when I find the sum of my absolute deviations, I come up with the value of 16. I'm going to divide that by my 8 data points to say on average the MAD is 2 beats per minute different. Which means on average, in reference to the average, 2 beats per minute more or less is where on average things are. So if we're talking about variability, does this show high variability or low variability? Low variability. So why is this a 2 when the interquartile range was a 3? We're referencing the average versus a distribution, right? It's a different measurement of central tendency. It's kind of, but they both show low variability. Yeah, it's kind of cool. Let's look at, let's pause this in case anybody needs to write anything down for a moment. So for question 2, there's another data set. And all the beats per minute are either 3 beats per minute more than the average or 3 beats less per minute than the average. So what's the, do we have enough information to get the mean absolute deviation? Well, we know they're all either 3 more or 3 less. Exactly. So we could just imagine if it's 3 more, 3 less, 3 more, 3 less, 3 more, 3 less, 3 more, 3 less. Divide that by how many there are. What's the average always going to be? 3. So we know it's 3. Yeah. We know it's 3. Because it said all the data is either 3 more or 3 less. So all the data is exactly how many away from the average? 3. Which means our mean absolute deviation has to be 3. Cool. Now, we got these pennies on a meter stick. That's number 3. Right? What's halfway in a meter stick? What's the 50, right? Or 50. So all the ways 100, none of the ways 0. Okay, and the mad is 10 centimeters. So what information does that tell us about the placement of the pennies on the meter stick? From the middle. On average, how far are they away from 50? Yeah, 10 centimeters away from 50, on average. We don't know if it's more, we don't know if it's less, we just know on average. These pennies are placed 10 centimeters away from the 50.